Another way to write a function is y equals a bracket x minus h bracket squared plus k, where the following occurs. A will tell us which way the graph opens. If a is greater than 0, the graph opens upwards, so it will look like this. If a is less than 0, the graph opens downwards, so it'll look like this. And the values h and k are the vertex of the graph. Now this is h, and that's k. K is exactly as you see it, but if you look in the equation, we have x minus h. This is just asking for that h piece. So for example, if in the brackets I have x minus 6, this would have been x minus h, so then h is equal to 6. If I had had x plus 3, well, if I write it in the same format as this, that would have been x minus negative 3. So there's my x minus, there's my h, and this time we now end up with h equaling negative 3. So this h value is going to be the same number as this, but the opposite sign is what we have inside the brackets. Example 1. Sketch the graph of the following function and state the domain and range. So as we go to look at it, we have our equation. If we write our vertex form underneath, we have y equals a x minus h squared plus k. So this is telling us that we have a vertex of. Now, when we go to look at it, here's our h, there's our plus 6. Well, at the opposite sign, this would have been x minus negative 6 inside the brackets. So we have a vertex of negative 6, comma 1, where this is our h and this is our k. So looking at our equation, a is equal to negative 1/2. Recall that when a is negative, the graph opens down. So by looking at our a, we know that our graph opens downwards. So we have a couple of things we can do. We are able to plot this point. We know the graph's going to go in this direction. But for us to know how wide or how narrow this graph is going to be, we'll need another point. One of the easiest ones to find is our y-intercept, because x is equal to 0. So we need to find a point. And we said the easiest to find is y-intercept, which was where x is equal to 0. So, taking our equation up here, we're going to put 0 in for x. We have y is equal to negative 1/2. 0 plus 6 squared plus 1. And as we go to solve this, you can do it all in one step in your calculator. And when you do that, you get negative 17. So that tells us that our graph is going to cross the y-axis at negative 17. So as I go to look at my graph, I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So counting by ones isn't going to get me to negative 17. But if I count by twos, negative 2, negative 4, negative 6, negative 8, negative 10, negative 12, negative 14, negative 16, negative 18, negative 20. So negative 17 would happen partway between negative 16 and negative 18. So we're counting by 2's in this direction, looking across 1, 2, 3, 4, 5, 6, 7, 8, 9. 6 will have us over here if we use that as our vertex, so it's probably easiest to count by 2's in that direction as well. So for this point, we're looking at -6, so -2, -4, -6, up to 1. So there's our vertex, and so we have our graph going this direction. Now recall, we do have that ability to make a mirror image, so we have one piece. The other side would probably help us if we have a point there. Now there's our axis of symmetry, and it is a mirror image. So if we look at this point here, it is 1, 2, 3 away from the line. So we'll have a mirrored point on the other side, 3 away from the line. So 1, 2, 3, there's the mirrored point. And at this point we can now come down on this side. And there's our graph. The other thing we were asked to find was the domain and range. As this graph keeps coming down, it is moving sideways. So we're going to get a domain that is, x is all real numbers. And then for our range, there are no points above 1. So 1 is our spot. The graph does keep going down and continues to go down. So we're looking at y and 1. Because of these values here, any of the values on the point on the graph are smaller than 1, that would mean that y is smaller than 1. And because we have our vertex at 1, we have smaller than or equal to 1. Donald measured the length of the shadow cast by a meter stick as 47.0 centimeters at noon and 198.2 centimeters at 4 p.m. Determine a quadratic function using Donald's data. Note, there is a minimum at noon since the shadow is shortest at this time. Alright, so if we go back and look at the information, we know that at noon, our stick is 47.0 centimeters for the shadow, and at 4 p.m., it is 198.2 centimeters long. Now, a couple of things we figured out and we've been told. We told that we had a minimum at noon. So if we can figure out the point for noon, that's going to be our vertex. Now we're going to need some points. We have our distance is going to be our y value, so how long that shadow was. Noon would be the same as 12. So we have 12 as our x value. Now, we said that this was going to be our vertex since it was our minimum. And if we look at this, this would be our h value and this would be our k value. So what we have happening is we have the ability to use our vertex form, provided that we have another point. We do have some other information about our shadow. We are told that at 4 p.m. it is 198.2 centimeters long. Now we can't use 4 because then we're going to be back near the beginning, and 4 a.m. and 4 p.m. each time should have a different height. So what we're going to need to do is use that 24-hour clock. So as we go to do that on the 24-hour clock, 12 p.m. is 12. 1 p.m., well, after 12 comes 13. So 1 p.m. would be the same as 13. 2 p.m. is 2 after 12, which is 14. So if I'm trying to convert 4 to the 24-hour clock, I'm going to take my 12, I'm going to add 4 hours to it, and that gets me a value of 16. So my time for this point would be 16, and my y would be 198.2. So, as we think about our equation, we have y is equal to a, x minus h squared plus k. H and k get substituted in, so we have y is equal to a, x minus 12 squared plus 47.0. Now, just like when we're dealing with the factored form, we do want to have a number there for a, not a. So we're going to use the point we have. So we're going to use 16 and 198.2 to find a. Recall this is our x value and this is our y value. So we now have 198.2 equals a times 16 minus 12 squared plus 47.0. And at this stage now we are solving for a. So simplifying this part, so we have this down to one single number. We have 198.2 equals a. 16 minus 12 is 4 squared plus 47.0, and then 198.2 equals a. 4 squared is 16 plus 47.0, and now we're down to needing to move numbers away from a. So number farthest away from a is the 47. It was being added. So we're going to subtract 47 from both sides. When we do that, we get 151.2 is equal to a times 16. And then that's a times 16. So dividing both sides by 16, we get 9.45 is equal to a. Now this a matched up with the a that we had right here. So we're going to take this a value, we're going to write it all the way up and substitute it in right there to get our equation. As a result, our final equation will be y equals 9.45 times x minus 12 squared plus 47.0.